Fish amino acid, also known as FAA, is a liquid fertilizer made from fish scrap. It is of great value to both plants and microorganisms in their growth because it contains large amounts of nutrients and various types of amino acids that will constitute a source of nitrogen for plants. On the other hand, hydroponics is a system that allows plants to grow in a nutrient-rich water environment. It may be beneficial to areas and communities with less field and more concrete since it can maximize space. Other perks would be that it requires less manpower, conserves water, reduces the supply chain, and makes crops grow faster and better, given the right climate conditions. The limited availability of space in highly urbanized areas hinders the feasibility of conventional farming methods, making it difficult to establish and maintain productive agricultural systems. The lack of edible foods lead to hunger in numerous areas in the country. Without the supply of crops, many people would not be able to fill in their stomachs and get the nutrients they need. As a result, many people face even greater challenges in accessing fresh and nutritious food sources. Hence, the project may significantly contribute to urban gardening and community planting systems due to its said efficient and independent aspects. The objective of the study is to determine the efficiency of hydroponic system that only submerges water-based plants in water, specifically to check whether the plants can survive in this type of system and to check whether the plants will thrive better in this system. It will also determine the effectiveness of the FAA fertilizer on plants growing in a hydroponic system. Our null hypothesis is that the hydroponic system and FAA fertilizer has no effect on the growth and survival of the plants. And our alternative hypothesis is that the hydroponic system and fertilizer will have a positive effect on the growth and survival of plants. A total of 6 plants were grown in the hydroponic setup, namely taro and herbs such as basil, mint, oregano, malabar spinach, and celery. The water system consists of a mixture containing rainwater, azolas, and duckweed. This setup was continually adjusted in accordance to different conditions, such as too much sunlight, too little shade, and too much water. For the herbs, the initial setup was placed suspended with the help of sticks and ties. However, due to its instability, the main setup was adjusted wherein they used a fly food cover and rocks to elevate the plants to about 3/4 submerged in water. It was located directly under a banana tree and slightly below a few large trees, giving access to both sunlight and shade during the morning and afternoon. However, about 2 weeks after, the location was changed to an area with more shade. These setups were then observed for 1 month. Additionally, FAA fertilizers were sprayed to the plants from time to time, especially to the plants that appeared to be receiving less nutrients than they should have been. The taro plants placed under the shade and those exposed to full sunlight were able to thrive in the hydroponic setup. However, it was noticeable that the taro plants grown in full sunlight demonstrated a significantly better growth compared to those grown in the shade. In the case of herbs, the study found that excessive sunlight exposure resulted in detrimental effects during the initial 2 weeks. The herbs exposed to higher sun exposure showed signs of wilting, discoloration, and dryness. However, after relocating the herbs to a more shaded area, there were improvements in their growth, such as greener leaves, healthier stems, and in some cases, the emergence of flower. The FAA fertilizer also aided the growth and survival of almost all plants due to the nutrients found in the fish scrap. Unfortunately, the celery did not survive the study. Ultimately, the researchers concluded that taro plants and several herbs are adaptive to the hydroponic setup, while emphasizing the significance of providing appropriate light conditions to optimize their growth and development.